Okay, so I want to go over the exam 1 first, and what I'm going to go over right now are the problems that I don't have to work out, and then I'll make another video that contains the problems that did require some work to be input. So the first thing that we want to look at is the true-false. The first question was elements in series have the same voltage. That is false. Elements in series do not have the same voltage. The voltage divides across elements in series. So elements in series have the same current. So that question was false. Question 2, current will divide between two resistors that are in parallel and the largest current goes through the smaller resistor. That is true. Question 3, the sum of the voltages around a closed path is equal to 0. That is true. That is Kirchhoff's voltage law. Question number 4, voltage sources that are in parallel may be added to find an equivalent source. That is false. Voltage sources are added in series. And question 5, resistors are always passive elements, but sources can either absorb or deliver power, and that is true. Now I will walk through with you how you would do question 6. I don't think it really necessitates that I work it out for you on a video, so I will provide the work itself. Basically, you were asked to find the voltage drop across the 4 ohm resistor. So if you note this 5-volt source, positive at the top, negative at the bottom, we discussed that in one of the videos with that battery symbol, which is positive and which is negative. And that's all over all kinds of textbooks. So Tesla's open book, no reason for you not to be able to either know that or be able to find it. Now what happens is this is set up perfectly. If you look here at the top node and the bottom node, which they've labeled 2 and 3, the voltage between node 2 and node 3, the total voltage of 5 volts is known. So what happens is that voltage divides between the 4 ohm resistor and the 6 ohm resistor. So this is the classic voltage divider. So the formula would be you would take 5 volts, you would multiply it by the ratio of the resistor whose voltage you want, which is the 4 ohms, divided by the sum. So it's 4/10 of 5 volts or 2 volts. You should be able to review the voltage divider and find that easily. Okay, I believe the next question asks us to find the current in the 10 ohm resistor. So once again, the 10 ohm resistor is connected to node 2 and node 3. And so that means since the voltage source is also connected to node 2 and node 3, they share 2 common nodes, which would mean that they're in parallel, which would mean that they would have the same voltage. So you would have 5 volts across that 10 ohm resistor. So what were we asked for? The current. We were asked for the current. So V is I times R, so I is V over R. So you take your 5 volts, you divide by 10 ohms, and you should get 0.5 amps. So no partial credit was given on these 2 questions because they were so simple. So I was looking only for the right answer. If you didn't have the right answer on this question, it means you fundamentally did not understand voltage divider or things in parallel having the same voltage, and that was a very simple. As long as you had those concepts, you can virtually do that problem in your head. Okay, questions 8 and 9 were a question about is the connection valid. In question 8, the connection is not valid because you have a 5-volt source with the positive end at node 2 and the negative end at node 3. And then you have a 5-volt source with the positive end at node 3 and the negative end at node 2. So those are opposite in polarity, which is not allowed when 2 elements are in parallel. They must have the same voltage. So the only way that could be valid is if either source V1 or source V2 were flipped. Okay, now coming to question 9, is it valid or invalid? The main thing that we need to look at is does this satisfy? First of all, it's perfectly fine to have current sources in parallel. That's not a problem. Then we need to look and see, does it satisfy KCL and KVL? So KVL, because the voltage in the current sources are unknowns, that could be satisfied, no problem. KCL, if you were to write a KCL equation at node 2 and say the sum of the currents leaving the node has to be equal to 0, you would have minus 2 amps plus 1 amp minus 1 amp. That does not equal 0, hence this connection is invalid since the circuit does not obey KCL. Okay, I also want to do this one without actually making a video of me working the problem. So let me just say you were asked to find the equivalent resistance at terminal pair AB. So we have a 30 and an 18 ohm in series. You combine those, you get 48. That then puts the 48 in parallel with the 24. And if you just literally plug into the formula, you get the correct resistance, 16 ohms. And then 16, 12, and 10 are all in series. You add those, you get 38. And I do want to say one thing. I did misspeak. This test was not open book. So I forget what I was specifically talking about when I said the test was open book. But it was not open book. However, it was still just really trivially simple. Okay, I think from this point, we can look at question 12. So what you had to do in question 12 is you had to look at each value. So for example, for element A, you have a negative voltage and a negative current. When you multiply those together, you'll get a positive number. But the formula has to be written with a minus sign because the current's coming out of the positive terminal. So that's going to give you a negative power in element A, which means that the element is delivering power. The same will be true for B and C. So you're looking at three things. You're looking at the sign of the current, the sign of the voltage, and when you multiply those together, what is the sign of the multiplied of the power? And then you're also looking at, is the power drawn according to the passive sign convention or not? So in B, when we multiply 18 and 45, we get a negative. And then if we look at B, it is drawn according to the passive sign convention. So when you get a negative and it's drawn according to the passive sign convention, that means it's delivering power. But you don't put a negative sign in the formula. It just comes from the V and I. So anyway, if you proceed with that on each element, you find that A, B, and C are delivering power, and D, E, and F are absorbing power. So once again, on that one, there was some partial credit. So for example, if you put A and B in something else, you got credit for A and B, and then you lost credit that you put something that wasn't delivering, and you lost credit that you didn't put C. But there was partial credit given on question 12. So question 13 is another problem that I want to work out on the iPad. So that's the discussion for questions 1 through 12 with the exception of 11. And I'll work 11 and 13 out so that you can see it worked. But I think this is enough explanation for you to figure out kind of what you're looking at as far as the grading. Once again, most of the questions, with the exception of question 12 and even the ones, even number 11 and number 13, they were so trivial that we actually did not provide any partial credit. These were like one-line problems. All right, so I'm going to conclude this video and post it and have it available for you to review for exam 1, and then I'll work out those two problems using a different software so that you can actually see me work them and have that available as well.